Hello again, everyone. Uh, Welcome back to CCCS121, Programming 2 at the University of Jeddah. So today I'm going to show you an example of a program that exemplifies um, the good practice of encapsulating functionality into classes. Uh, Also, so far, most of the classes, maybe even all of the classes that we've seen, uh, were basically storing data and just providing methods to access that data, either to write in a new value using set methods or to retrieve those stored values of member variables using get methods. But there was little else that the classes that we've been coding so far, there was little else that those classes did. So we're going to change that today, and we're going to add some slightly more interesting, some actual functionality into a class that we'll make today. Um, so what we're basically going to do is we're going to design a class called loan, like the loan that you take from a bank. Uh, and what this the functionality that this class will provide is uh, it will store an annual interest rate. So the interest rate that the bank charges you on that loan, the number of years over which that loan will be repaid or paid back, uh, the amount of the loan, of course. There'll also be a date that we'll be storing just for fun. And so obviously we'll need some methods to update these member variables, to put in an interest rate, put in to specify the number of years for which that loan will be repaid, the amount of the loan that we want to borrow. Um, so that's pretty much what we've been doing so far. But in addition to that, this class will also do some calculation. It'll do some work for us. It'll do is if you give it uh, these three values, you can see over here in the methods section of the loan class in this UML class diagram. Um, that, 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 It'll give you the monthly payments, and it'll also give you the total payments. So it'll tell you how much you have to pay every month uh, for this number of years at that interest rate uh, for a certain loan amount. So it'll tell you what the monthly payment is, and it will also return to us the total amount of money that will end up paying the bank. So a lot of the same information that you usually get when you're applying for financing for a car, for example, when you go buy a car. In this loan class, there's no provision for any balloon payments or upfront payments. So this is slightly more simple. But you can see that in order to calculate these monthly payments, the total payment, we have to end up using these data members, but we also have to do some calculation. We have to we have to do some work in this method. So this is actually uh, kind of representative of classes that you actually end up using in many of your projects. Um, we see in this UML class diagram that all the data members over here are private. All of these methods to set and get different values, to even to get the monthly payment and the total payment, we will keep all of those public. So on to it then. Um, let's begin by coding the class, and then we'll do the main function, the main method. So first off, let me add a new Java class called loan to this project. There you go. And all straightforward. We have these 4 data members. First one is double the annual interest rate. Another private member variable is the number of years. As you can see, this is an integer, which means it has to be a whole number. It cannot say 1.5 years. You cannot specify that. Okay, number of years, we got that. What else? The loan amount, of course. So how much loan are we taking on? And we also want to keep track of, let's say, the date that this object, this loan, an object of the loan class is created. And for that, we'll use the Java util, the date class in the Java utilities API. Okay, that's basically all the data members of this class. And let's move on to the methods. First, let's add a default constructor. Constructors are always public, don't return anything. And I'm also going to make another constructor. We can do that one first, actually. So public loan first will be interest rate, then the number of years, and then a loan amount, and you can see that the names of these parameters to the constructor, the names of these variables are the same as the names of the member variables. So from last class, you know that in order to distinguish between member variables and method parameters, I have to make use of this keyword, number of years. There you go. It's equal to. But it makes the code a lot more readable and easier to understand. See, fewer variables. And let's also take this opportunity to initialize the date variable, the date object, with the current date. There you go. Okay. And if nothing is provided, I'm just going to provide a default interest rate of 2.5% over 1 year and a default loan amount of 1,000, whatever the currency. There you go. We have the 2 constructors. I'm just going to copy paste. I'm going to spend time that's not needed. Okay. Next, let's provide some accessor methods. So get and set methods. Sorry. So public Let's start with accessor methods, so get methods. First one, get annual interest rate, and this will return the annual interest rate. Next, let's match these up. Set annual interest rate, take a double, interest rate, and assign this dot annual okay. There you go. Next, the number of years. Is an integer. Get number of years. Returned number of years. Next, set number of years. This dot number of years is equal to number of years. Okay, forgot a dot over there. Oh, okay. Okay. And there's the loan amount. Public. It's a double. Get loan amount. Returned loan amount. And set loan amount. This dot loan amount is equal to loan amount passed as parameter. And see anything else? Oh yeah, how about let's public Java util dot date get loan date. There you go. So now we have all the set and get methods that we needed. And here's a new part that we're going to do this time. Public double get monthly payment. So we're going to have a method like that. Okay. And so in here we'll do the calculations necessary to calculate the monthly payment. So to do that, we're going to do that in two steps. First, we calculate a monthly interest rate, which is the annual interest rate divided by 12 because we have 12 months. Another thing, the interest rate over here is specified in percent. So we're going to divide that by 100. because 100% is mapped to the number 1, 0% is mapped to 0, so we scale that, the percentage, to a number between 0 and 100, to a fraction. Okay. And interest rate, so this is a monthly interest rate, and then we're going to use the monthly interest rate to calculate a monthly payment. And look this up, calculate it in this case as the loan amount multiplied by the monthly interest rate, and we divide the whole thing by, take this to the next line, it's kind of like a fraction actually, so 1 minus, so actually, so I don't expect you to know this, so the math, the dot pow method, this is if you want to take an exponent, so a to the power b, x square, stuff like that. So I guess you could say that if you were a banker, then we would know these things, but for now, for this little project, I'm just going to copy this. Okay. Over 1 plus monthly interest rate to the power number of years times 12. So I'm going to trust the math on this, and this is too much. Okay. So supposedly this will give us the monthly payment, which I then return from this method. I return monthly payment, this value that I just calculated over here. Okay. And then we have one other method we have to complete. This is the one that gives us the total payment, and this is actually easy and common sense. So total payment is simply the monthly payments, which we can get by calling the get monthly payment method, multiplied by the number of years times 12, because there are 12 months in every year, right? And simply return total payment. That's it. Our loan class is done. So if I ever give you in the exam or for an in-class programming exercise, you can consider this math, that this calculation that went into the get monthly payment method, you can consider that domain specific information, domain knowledge. So a banker would know this, you might not, which means that this is the kind of equation that that you can expect that you will be given. this, I'll explain to you, this is a calculation you have to do, and um, inside a certain method at some place, and you can just use that. You don't have to figure this out yourself. Okay, so I think we're done with the loan class. Let's now go to the main method and make actual use of this class. So as you can see, I already added one line to the um, test class that contains a main method. We are going to get input from the user, which means I need the scanner class. So I'm going to import Java util scanner. I'm putting that right up here before the class that contains the main method. So this is before I do anything, I'm going to create a scanner object. I'm going to take input from system.in, which is the keyboard. So create create a scanner, do that, and using the scanner, I'm going to ask the user for first of all, I'm going to ask for the interest rate being charged. So enter yearly interest rate. After that, enter number of years, followed by how big the loan is, what the loan amount is. Once I have all of that information, I then create the loan object of the loan class, and I'll calculate the monthly and total payments. Display loan date, monthly payment, and total payment. So this is the plan. So now so as you can see, I started with by writing the comments first. So basically that's a way to think about how you're going to approach a problem. Now I just have to add the appropriate code after each comment. This is usually a very good practice. Also helps make your code more readable. Okay, so enter interest rate. We want to get the interest rate from the user. What I'm going to do is before I do anything, I'm going to print out a helpful message for the user. I'm going to say, think about this. I'm going to print out something like enter yearly interest rate. For example, 8.25 in percents, just to make it clear. Okay, and then I'm going to call, and I'm going to use the scanner object I already created up here. And I know I want the interest rate is going to be a double number. So the annual interest rate is equal to input dot next double. This is how I read a double number from the user from the keyboard. Notice something, that We already used annual interest rate as a variable for the get interest rate method. That was a local variable that existed only inside that method. We also have annual interest rate as a member variable of the loan class. This is another uh, uh, double variable called annual interest rate. This is also a local variable. This is local to the main method. This is not the same variable as the one in the loan class. Okay, this exists only in the main method. We need this in order to store the input we're getting from the user, from the keyboard, and we're going to pass this to the loan object, to the constructor of the loan object later on. Okay. Okay. Next, I need to know what the number of years is for the loan. So enter number of years as an integer. And I'm going to use number of years. Again, this is a local variable. I'm going to call the next int method on the scanner object, on the scanner object input. Sorry, and then I'm going to ask, of course, for how big is the loan going to be. Enter loan amount. For example, this can be a double. So just to make sure that it can be a double. There you go. And again. Oops, small m. I'm going to call the next double method on the input scanner object. Now I have all the data I need. I just need to create the loan object. I'm going to do that like this: loan small. The object name is also going to be loan, but with a small l. Remember, Java is case sensitive that way. And in the constructor, I'm going to pass the annual interest rate from up here, the one you can see is already highlighted. So the IDE is recognizing this as the same variable. The number of years recognized as this variable up here, and the loan amount recognized as this local variable. So this will create a loan object, and then I'm going to print out the date, the monthly payment, and the total payment. So system.out.print. Okay. So I'm going to format. So see, I'm using printf. Printf is different from print and print line. I can put in formatted variables in the string. See how that looks. So for example, I want to print out 3 values. The loan was created on, I want to print out a string. So percentage %s is a placeholder for that. It's going to be a new line. And next line, what's going on? Auto completion. Some autocomplete going on over here. Just a minute. This. Yes. Okay. And on the next line, the monthly payment is, and I want to display this monthly payment. Remember, that's a double, but I only want to show it up to 2 places of decimal. So F for float or double. So I want to display a floating point number over here, but only up to 2 places of decimal. So I put a 0.2 in between the percentage and the F. And then a new line. Next line, the total payment is also a floating point number, and I'm also going to show that up to 2 decimal places. So I'm putting a 0.2 over there. Then a new line after that, and I think that's it. Now I have 3 variables, 3 placeholders in here. That's the problem. I have 3 placeholders here: a string, a floating point number, and another floating point number. Now in Printf, when I'm using the Printf command, I can specify what those 3 placeholders will display. So in the first place, I want to show the date. So loan dot get loan date. So the second placeholder is over here, is the monthly payment, which is going to be the value returned from loan dot get loan dot get monthly payment. And then in the third place over here, I want to display the total payment, which is returned by loan dot get total payment. Let me put these all. There you go. So I have to provide 3 arguments over here. One, what's going to show up in this place of this string, what's going to show up in the place of this floating point or double number, and another one for this floating point placeholder or double number. It's going to be the loan date, monthly payment, and total payment. I think that's it. Okay, let me try and run this. There you go. Hope we have no errors. Huh? Worked the first time. Okay. So, program is asking me for the annual interest rate. Let's say I want to get a loan for 4%. There you go. And I want to pay back that loan over 3 years. And let's say I want to get a loan for 100,000 real. There you go. So this calculation was performed Monday, October 8, 10:52, which is right now. The monthly payment is 2,952 real and 40 halala. And the total payment will be, the total amount of money I will have paid at the end of 2 years, the 3 years, sorry, is 106,286 reals and 35 halala. Works pretty well. So try it out a couple of times. You can try it again. Maybe this time 5% interest rate over 5 years, and a loan amount of 250,000 real. There you go. Much more expensive, this loan. Okay, so um, this is an example of a class that not only stores uh, member variables and provides get and set access to them, but it also does some work. It does some calculation with those numbers. Okay, it calculates a monthly payment and the total payment in this case. And this is much more representative of the kinds of classes that you will be developing in projects of your own. Okay. Now in the lecture slides, there is another example of a class called the BMI class, Body Mass Index class, which kind of does the same thing. It contains some member variables, and then it does some calculation based on those member variables. Um, Another thing you'll notice over here is if you look at the UML class diagram, this class BMI has a name string, fine, contains an age parameter, an integer, a weight, and a height of a person, and it calculates the body mass index, which is a number based on which you can determine whether or not you are overweight or the right weight for your age and your height. Take a look at the methods section of this UML class diagram. I'm not going to do this whole class in this video, but because the code for it is given in the slides, so that's the reason I'm not doing it. There's also a test class, a main method to test it out, but you'll notice that there are no get methods or set methods for the name, age, weight, and height. Now, obviously, you have to put something in here in order to make use of this class. Now, one way to do this is to make this an immutable class, and you can say that, you know what, you have to specify these items, these data members, you have to specify them in the constructor. But more often, what happens is that because the get and set methods can take up a lot of space over here in this UML class diagram, what we usually do is oftentimes we just skip them. We just don't put them in here because it is understood that when your class has data members, you will provide get and set methods. So from now on, get and set methods in many of the UML class diagrams that we'll see, they will be omitted. We'll just skip them. You are supposed to understand, you're supposed to know, you're supposed to figure out using common sense that yes, there will be get and set methods for member variables, and we're just not going to put them over here because, as you can see, for 4 member variables, we'd have to put in 8 methods down here. So there's really no point when we all know what they, by now we all know what they do. Okay. So that brings us to slide 17 of the lecture slides. It's actually, it gets us past 17, gets us to 20. And I guess we'll be able to finish this set of slides in our Thursday class, by our Thursday class this week, end of this week. So assuming our first midterm exams start next week, you can be sure that this set of slides will be included in midterm 1. Okay, so I'll see you all in our Tuesday class.